So welcome to the Helix webinar series. Today's session is on From Legacy to Leading Edge, Leveraging OpenTelemetry metrics with BMC Helix AIOps. Joining us today is John Ahern, our Principal Solutions Marketing Manager. He will do his formal introduction shortly. And then we're also joined by Sentry Software. This is our second session this week. So we welcome in Bertrand Martin, the CEO. And we've also got joining him Razim, our pre-sales consultant. And along with the team, we've also got Amol Rastogi, our AIOps product manager. He will be there in the panel to answer any questions AIOps related. Before I hand over to John, just a couple of reminders. We do have the Q&A section of Zoom. And while we're doing the presenting, we would love you to put some questions into the Q&A. Let's keep our panelists busy. And I'm also going to be launching a poll as we speak. We would love to get a bit more information about how you're using your technology today. So if you can try to fill that in as the session goes on. And then at the end, we'll have time for live Q&A where we will unmute you. So with that, John, I'm now going to hand over for you to get us started and then hand over to Bertrand.
Thanks, Samantha. And welcome to everyone on today's call. So, good morning, good afternoon, good evening, wherever you are. But I'm really excited to share this presentation with everyone today. So leveraging OpenTelemetry metrics with BMC Helix AIOps. As Samantha mentioned, my name is John Ahern and I work on the solutions marketing team. And I work closely with Sentry Software, who we're going to be hearing from later on today. I'm delighted to be joined by Bertrand and Razim and Akil from Sentry today. So what we're really going to be looking at today is a bit of the background on OpenTelemetry. I think if we can flick onto the agenda slide there, we're going to get an introduction to the background of it. We're going to have a look about the OpenTel collector, how BMC is leveraging, I guess, OpenTelemetry. And then the exciting bit, Bertrand is going to take us through some really kind of cool demos towards the end of it. But as Samantha mentioned, we've got lots of different opportunities for everyone to engage in today's webinar. So we'll be on the chat, we'll be using Q&A, we'll be following up afterwards with questions and links and documentation. And also we'll be closing out with that poll as well. So I'd like to hand over to Bertrand. And as I said, we'll be on chat, Q&A, keep engaged throughout this one, and we look forward to catching up with you after today's presentation.
Thank you, John. Thank you, Samantha. So I'm Bertrand, and yes, we have a lot of content, some technical content as well, and a couple of demos. Hopefully, nothing will crash. But before we dive in, before we jump into all the exciting OpenTelemetry stuff, let's first quickly, recap how we got even here. Starting from the dark ages of IT monitoring. Well, I mean the 80s. So back then, supervising IT systems, for guys like me with some experience. It meant manually checking, if your servers, I used to be a server administrator, by the way. So manually checking your servers, making sure that they were running, and occasionally relying on some vendor-specific proprietary tools. That wasn't glamorous, I have to say. But soon, companies like, pioneers actually in this field, pioneers like BMC, IBM, and HP, stepped up and introduced agent-based tools. Now, agents are cool again. And if you have my age, you probably remember, or at least heard of, Patrol, Tivoli, OpenView. I even put a very nice screenshot of the legacy BMC Patrol classic console here, just for the fun. And so these agents were revolutionary at the time, bringing a basic graphical user interface and centralizing the way to monitor your infrastructure. So then, moving into the 90s, things get a bit more standardized. SNMP became the go-to protocol. for networks. Microsoft gave us WMI, infamous WMI, and WebM with the DMTF tried, although they didn't fully succeed, they tried at providing a universal management standard, and then we finally had monitoring agents connecting metrics everywhere, even correlation to reduce alert fatigue, because everybody knew the Christmas tree back in the days. Visual network topologies, that's got a bit better, right? And then another shakeup within the early 2000s, where open source solutions entered the game and changed everything again. Nagios arrived in 1999, free, modular, extensible, etc. Yeah, but it needed a lot of manual configuration. But people loved the flexibility, and then we had tools like Zabbix and Cacti, etc. So, and then we had the explosion of complex infrastructure, clouds, data center, virtualization, and so the traditional players, I had to adapt, trying to add automation, orchestration, cloud integration. So we saw the likes of SolarWinds, Managed Engine, etc., trying to handle AWS and Azure, where BMC actually was pioneer in this space again. And we saw new standards coming up with Redfish, server management. But that's the catch. Traditional monitoring started hitting limits, like how to monitor microservices, containers, and dynamic environments, not made with the static dashboards, etc. So it became inadequate. So that's when we started talking about observability, smarter, deeper approach, looking not just at metrics and alerts, but also at logs and traces and correlating everything. And then we saw OpenTelemetry, Prometheus, Grafana, and actually to show that here. So how did observability emerge itself? So if we actually get back to the 90s, the first who introduced that were Sun Oracle with a Java, with what we call a JMX. It's still around, by the way. JMX, Java Management Extensions, it was cool at the time because, it allowed anyone to peek inside a JVM and manage components on the fly. But it was limited to Java. And frankly, it wasn't easy to deal with. And so then in 2000, the company started realizing that they needed better instrumentation inside their applications, inside their own application. So new tools emerged like, App Dynamics or New Relics, etc. Great solution, sure, but, mostly proprietary and limited to specific tech stacks. And then, things started changing, fast, the explosion of microservices. So these new architectures made us it made understanding the systems, harder and harder. So yeah, it wasn't just about logs or metrics. You needed to interconnect everything, and so we got logs analytics with the Splunk. We got Graphite for metrics, and suddenly everything seemed a bit better, but still separate and still specific. Each vendor had its own way of doing things. And that's when we got OpenTelemetry in early 2020. So it's actually Open Tracing and Open Sensors who merged together, and they created. It became OpenTelemetry, so an open source standard hosted by the CNCF. The CNCF, it's the open source organization that cloud native that hosts the Kubernetes and the famous KubeCon events. And with OpenTelemetry, so in OpenTelemetry, sorry, it's I'm gonna explain a bit more about OpenTelemetry. OpenTelemetry is it's hosted by the CNCF, where competitors in the observability space, cooperate, together. They work together to define a standard, a way to interoperate. So we have the likes of Splunk, Grafana, Cisco, Microsoft, AWS, etc. All these guys who are competing are actually working together. And in these companies working together, so there are these competitors, there is now BMC Helix, there is Sentry Software, my company. We are contributors to the OpenTelemetry project. So it's open source and it defines, it's not a software, right? It's just a standard, and it defined three main things: a protocol to exchange data. Then it created SDKs, software development kits, so that application developers can use this standard. And then they created what they call a collector, but it's really more a pipeline. I'm gonna get back to this later. And I will talk about SEMConv, which is semantic conventions, later too. So they defined protocol in a data format, SDKs, and they created a collector to cover the three main signals in observability, the three main pillars that we call the main pillars of observability, which are traces, logs, and metrics. Well, now they're adding new stuff like baggages and events, but let's focus on metrics, logs, and traces. So mainly, as I was saying, observability at first was about traces. It was about making an application observable. That is, well, it was natively instrumented so that any observability framework could, get data, calculate, stuff about it, analyze its response time, its performance, its availability based on signals emitted by the application, without entering into debug mode for the application. Traces. So how does it work actually? Let's take an actual example. Application observability in general, and well, in OpenTelemetry in general, it's basically about knowing the response times of the different functions and methods and services that are called inside an application. The service, typically user request calls a service, several services, which itself may be calling another sub-service, which we call a function, which we call a backend stuff, etc. And then you need to know if things are slowing down. You need to know which sub-service or method or function or backend function is slowing down the overall request and killing the user experience. And what does it happen often, etc. Or did that happen just for a few specific queries, etc., etc. So you need traces. So for an application, to know about the performance of an application, you need to actually modify the code of the application. So that's how observability works in general. Well, so in this case, you have two methods: get user, getting the details of a user, and then this one calls another function that fetches the user details from the database, and you want to know, what is taking some time. So how to instrument that application with OpenTelemetry. Well, they've made a lot of progress. It's just like that. Just add a few annotations in the code. Well, this is in Java, where you define spans, which will create traces in your observability framework. And in this case, you can get, you will see the performance of the get user request span, and you can, sort that by user ID, etc., because it's defined there. It's just like that. And you could actually even do that without these annotations, because now OpenTelemetry features provides what we call agents that will automatically, it's called auto instrumentation, and that will, so you take an application in Java or Python or whatever, and OpenTelemetry will try to automatically instrument, add tags, spans, traces, and logs to that application. So I was saying you need to modify the application, right? So let's say you have this application running in the cloud or in your infrastructure right there. Then, well, it's being developed by some developers here, right? Using, I don't know, C++ if you're really into that. Go, Java, Python, Rust, that's a new cool thing. So to implement application observability with OpenTelemetry, well, the developers have to update the application. So they add the SDK here and with the annotation that we just saw to the application. They deploy this new version of the application. So now it's deployed in my infrastructure. And then the application starts sending OpenTelemetry signals, traces, metrics, and logs to an observability platform through the OTLP protocol, OpenTelemetry protocol. Okay, and so as users use the service provided by this application, we will be getting metrics, logs, and traces in the observability platform. And here you see it's actually Stackify, excellent observability platform that was acquired by BMC Helix last year, I think. Can you see a bit more? You can see, oh, it's all blurry. I'm very sorry. Anyway, so you can see the different spans, the response time, and how much time it takes for the application to perform different, to complete different requests. Okay, but now that was the very, that was the easiest. That was the theory, right? Now, what if you the application cannot access the observability platform directly, for example, because there are components like the backend or that cannot access the cloud platform directly. What if well, the observability platform itself does not support OpenTelemetry natively? Some do, but not all do. And so in which case, how do you take the instrumentation information, the data emitted by the application, how do you take it to your observability platform? And what if you have an application that is not even instrumented with OpenTelemetry because you can't update it for some reason, because the language is not supported by OpenTelemetry, because you don't have the resources, whatever. How do you do? Oh, it's not an application. It's a device. It's a server, for example. It's a database server. It's a storage system. How do you take information from this thing to your observability platform? That's where you actually are going to use the OpenTelemetry collector. the OpenTelemetry collector, it acts really as a gateway between, well, anything really. Let's zoom in. So yeah, it's a lot of theory here, but it's not theory. It's actually, you need to understand how that works in the interest of the different components in OpenTelemetry. So this is the inside of the OpenTelemetry collector. So it's made of it has three main components. The receivers, which are you have receivers for different pieces of thing to collect data from the outside or to receive data from the outside. For example, there is the OTLP receiver, which will receive, well, OpenTelemetry protocol. You also have the HTTP check receiver that will be able to simply verify whether a web service is available or not. You have the log file receiver, which can pass some log files. You have the JMX. Oh, we talked about JMX earlier. JMX receiver will be able to pull a JMX instrumented application, a Java application. vCenter, for example, will be capable of getting data from VMware vCenter, if people are still running VMware. So this receiver retrieve data from the outside. And then these data, which can be metrics, logs, or traces, are then pushed into processors. And there are many different processors in the OpenTelemetry collector for aggregation, for enrichment, for filtering, because you maybe don't want everything that has been received here, or grouping, redacting, if you want to remove sensitive information, sampling, because you don't want all the data, transforming, etc., and also batching to make sure that you don't kill the observability platform in the backend. And then you have the exporters, and the exporters, well, there are exporters for many different platforms and different formats. So you can send the collected data, transformed data here. You can send that data to any of these exporters. There are 48 exporters for AWS, Azure, GCP, Datadog, Apache, Elastic, Loki. Prometheus is actually one of the main ones. And even, debug, file export, etc. But then, so actually at first, our first research with OpenTelemetry in BMC Helix was to send data that we collected, through OpenTelemetry, and to push that data using the Prometheus remote write to BMC Helix, because BMC Helix, well, it's a great platform. It has an endpoint to receive Prometheus data through that protocol. So we used that at first. And but that wasn't enough. So at Sentry, we decided to develop an exporter for BMC Helix in the OpenTelemetry collector itself. So it's not a separate thing that we develop on the side. We actually worked with the OpenTelemetry group. Actually, we integrated that group and proposed a new exporter dedicated to BMC Helix. And for now, it's managing metrics. We wanted to start with metrics because BMC Helix already has mechanism for handling traces. So we wanted to push metrics. And so there was a question of how to adapt OpenTelemetry concept to BMC Helix. This very interesting table summarizes the difference maps the concept of OpenTelemetry to BMC Helix, but it's it's a work that research that we had to do internally on how to map properly OpenTelemetry to BMC Helix. So for example, first of all, OpenTelemetry is much more basic than the data is less qualified than what we have in BMC Helix. BMC Helix, you have discovery, you have operations management, you have service management, you have dashboards, etc. And so the data that you have in BMC Helix is greatly qualified so that AIOps can actually run, detect, troubleshoot, and automatically fix things for you. When it comes to OpenTelemetry being a standard that has been defined, to be able to collaborate between different platforms, it defines the minimum. So that's so for example, in Helix, we have the concept of a device which represents a server, a network device, a storage system, for example. Well, in OpenTelemetry, it's mapped to a resource, a host resource. But we don't know much about the resource. Then in BMC Helix, we have monitors or entities internally. Monitor types, the type of the entity. And we have a hierarchy, this disk belongs to this server. This file system belongs to this server. This Lambda belongs to this account, belonging to this AWS structure, etc. In OpenTelemetry, it's defined as a resource again. It's the same thing, just a different type. Then, we have we have attributes that we need to map properly, and then we had an issue with OpenTelemetry defines different types of metrics, gauges, counters, up-down counters, and histograms, etc., etc. State set, which is a bit special, and attributes associated to the metric. And we had to understand how to properly map these two metrics in BMC Helix, and that will need a little processing to make sure that everything that we have on the OpenTelemetry side will end up properly represented in BMC Helix. So we were thinking of that, and then our own Nassim Boutekejait, who is attending the call, hey Nassim, joined the OpenTelemetry organization. So we created an issue in GitHub saying, okay, we need to create a new Helix exporter. We had to find sponsors there because you can't just arrive in the organization saying, hey, I'm going to add whatever I want. You need some approval first, and then Nassim actually went through the development of this exporter. So it's a new component in OpenTelemetry. It's an exporter. It's written in Go, as you can see here. Beautiful Go. OpenTelemetry is all written in Go. It has some benefits, but it has some some issues as well. And at Sentry we work Java shop. But anyway, we worked with Go as it was requested and created this this exporter, which got approved and published, and now in the official OpenTelemetry collector contrib distribution, you have an exporter for BMC Helix. That means that anyone who downloads the BMC Helix, the OpenTelemetry collector, and uses it to collect data from whatever, will be able to push data to BMC Helix. And what I want to say is, yeah, we've actually we already contributed to the OpenTelemetry project because we actually we had to implement some ways to transform OpenTelemetry metrics into Prometheus metrics to push that to BMC Helix back in the time. So I actually did that myself, converting metrics from OpenTelemetry to Prometheus. It was my first code written in Go. I'm not a Go developer. I'm the CEO of Century Software. So I wrote that little piece of code, just trying to transform, to convert units and stuff. And and so that piece of code was actually merged into OpenTelemetry and became one of the main components for matrix transformation, because OpenTelemetry uses a lot of Prometheus. Then the Prometheus project, they actually used my own code for consuming data from OpenTelemetry, which means that anything that OpenTelemetry that pushes to any Prometheus server nowadays goes through my little piece of code, and I can tell you this is very scary. Anyway, I don't want to brag about this. Let's go through our first demo. So, yeah, we'll start slowly. I'm just going to, I'm not going to develop an application right now in OpenTelemetry and push the metrics to BMC Helix. I'm not crazy. We don't have that much time. I'm going to set up an OpenTelemetry collector, actually running on my own PC. And I'm going to use the host metrics receiver to collect system metrics from my own laptop, and then configure the BMC Helix exporter to push the data to our demo tenant on BMC Helix. Let's go there. So first of all, what I did is just go to OpenTelemetry collector releases, download the Windows version. There are many. Yeah, they are compiling and packaging the OpenTelemetry collector for every possible platform. Wait a minute. What's the difference between Windows x64 and Windows MD64? I didn't even know that was a difference. Anyway, that's the subject. So I installed that on my laptop. Then I got the OpenTelemetry collector installed here. It's not started because I'm gonna start it manually. So basically, it's made of a what is it? When it's installs, it's a Go thing, right? In Go, that's it. You have just one single executable like that, nothing else, and a config file. So the executable is more than 300 megabytes, but that's it, nothing else. So that is practical actually, because there's no dependencies. That you always 100% sure the thing will run properly. And then I have one file that put in program data config.yaml, and I'm starting this OpenTelemetry collector. It's already started. Okay, all right. Stopping it. And so I just started this way, the executable here, ---- config, and then path to the config file, right? And now, again, don't freak out. We're gonna look at the config YAML file here. So this is the OpenTelemetry collector configuration file. It's standard. So it defines the three main components that we talked about earlier: the receivers, the processors and the exporters. Okay, and then you define the pipelines. I told you that the OpenTelemetry collector was actually a telemetry pipeline. So then you define the pipeline. So what data goes from which receiver to which processor to which exporter. So here, simply I have one receiver defined for just to receive OTLP, OpenTelemetry protocol. Then it goes through different processors, the batch, memory limiter, resource detection, which you not going to go into much detail here. And then I have one exporter, just, okay, check the configuration here, exporter. Prometheus check, which will just be listing on 24.3.7.5 to see what is actually what is going through in my OpenTelemetry collector. So if I go there, this page, there is nothing actually here, right? So I'm querying. So this is how you query a Prometheus exporter, by the way. You go on /matrix. So what I'm gonna add, I'm going to add this receiver. Okay, taking this one. Okay, I'm commenting it. Oh, at this spot. So it's the host matrix receiver that we saw just a couple of minutes ago, and then I'm configuring it so that it's gonna collect CPU, memory, paging, disk, network, file system metrics from my local system. Yeah, the OpenTelemetry collector can, this receiver can collect metric, but only locally, right? But I just want to see how that works. So I'm saving this. I go here, I stop, I start. Okay, now I go back to just checking whether if it's properly collecting. It is that. Oh, yeah, typical beginner mistake. So in my pipeline, so I have configured this host metric. So the component is defined and configured here, but I haven't put it in my pipeline here. In my receivers, okay, I don't even need OTLP here. I'm just gonna put host metrics, but it's not just host metrics, right? Oh, yeah, it's just host metrics. Okay, good. Yeah, I have Copilot who's trying to do everything for me. Sometimes it does silly things, but mostly it's okay. Okay, now go back here. You need to restart the OpenTelemetry collector to take into account the new configuration. And go back to just checking /matrix. Here I'm calling. Okay, let's go back. Yeah, okay. Actually, here I have activated another export. So I have host metrics running here, collecting data here, and I'm actually not using the BMC Helix exporter. I'm using the Prometheus exporter here. So it's just exposing this endpoint /matrix. I just want to see what's happening before going to BMC Helix. Okay, so it's we see the host receivers matrix being collected here. All right. Okay, now let's take that to BMC Helix. And go back to, okay. So I'm gonna add configure this exporter. And export to BMC Helix. Helix demo tenant. Okay, don't look at. I shouldn't show you my my private key here. Okay, so you don't see it. You haven't seen. You haven't taken any screenshot. Shit, still showing. So to configure this exporter, my exporter to BMC Helix, I just need to add these lines. BMC Helix. Yeah, I'm adding a tag because I will have several ones. The endpoint is okay. Let me show you my endpoint. This is the one. Yeah, this is checking that I'm still logged in. Yes. So this is BMC Helix and this is my tenant, right? Sentry2 item. So I just put that in my config. And then I said we need to do some transformation. And I said, remember I said, yeah, for host and monitors to define host and monitors, we need to define to set additional attributes that are called entity name and entity type ID to my metrics. So I'm gonna uncomment this part. This part is something that, so it's a transform processor. This is part of the processor. So okay, I'm adding a processor, transforming OpenTelemetry metrics and add the necessary attributes to see them properly in BMC Helix. If I don't do that, I will get the metrics in the data lake. I can see these in BMC Helix dashboards. But if I want to use BMC Helix operations management and discovery and create services and AIOps and use AIOps on this, I need to add the proper qualifiers, attributes to metadata to my matrix. And these are basically entity name and entity type ID. So I'm doing some transform. These, these transformation lines are we actually at Sentry, we do provide templates so that you don't have to do that by yourself. But I'm showing that to you so you can see the how it works internally. So I have that. I save my config. No. Again, I was going to do the same stupid mistake. In my pipeline, now I need to add my transform. Will be transform Helix, and the exporter will be BMC Helix demo. Yeah, I don't want the demo one. Okay. I will start it. Okay. So now we have, the host, my OpenTelemetry collector using the host metrics receiver to collect metrics locally, and then pushing that to BMC Helix. Let's check. Now it's working. And we can have this. Then okay, I need to go to devices. Oh, San Francisco, and I'll be going to change my filter to see thing. Then I will go with central Bertrand. And okay, there it is. So I don't have much here, right? But I'm seeing the metrics that I'm seeing the entities. First of all, I'm seeing the entities that are derived from the metrics collected by the OpenTelemetry collector. So for example, here I'm seeing my disk C and hard disk volume 4. If I go there, oh, I don't have any metrics there. It hasn't got enough metrics. Okay, maybe maybe the other one. Maybe the other. Okay, all right. Okay. Been collecting data here. All right. Okay. What is that? Okay. Direction, operation time, and disk I/O time. And these are the metrics that I'm collecting. That is being collected by the host receiver, right? So I got these metrics here. What do I see here? Memory. Okay. All right. So I'm seeing. Okay. Okay. I did run that before, and now I just got this gap here. Just restarted here. So this is the usage in bytes. We even have the unit of the metric that is propagated here. All right. So I have the memory usage displayed here. I can go through network, memory, paging, etc. These are the metrics collected by OpenTelemetry and pushed here. So now I can actually go and create an alarm policy. You can say, okay, I'm creating system memory, let's say, and for metric, system memory utilization, example, and then, okay, if metric is above 5%, then age alarm and do not close, etc. And that's it. Oh, what is that? Ah, a lot of content. Sorry. Okay, so the second demo was gonna do. I'm not gonna do it, but I wanted just to collect from Prometheus exporter. Yeah, have Prometheus exporters and then use the receiver to collect data from Prometheus. Like, we have Prometheus exporters for Kubernetes, etc., and push there to BMC Helix. Okay. Now, something else that we can do is integrate OpenTelemetry native collectors like MetricSub. MetricSub is something that we created recently at Sentry. It's a super collector but it pushes everything natively in OpenTelemetry, right? So the protocol, so it collects everything, from server storage systems, network devices, through SNMP, HTTP, SSH, WMI, API, WebM, etc., and pushes the data as OTLP, as metric, OpenTelemetry metric signal through OTLP. So then it goes through the OpenTelemetry collector, and then it goes through the BMC Helix exporter, and then it arrives in BMC Helix, where then it can be leveraged for alerting, for correlation, for dashboarding, etc. And we actually have this working right now. What is there? Where is it? Yeah, well, actually, basically, go here, monitoring devices, do this, and then I can go, well, actually, all these devices are collected by one collector, MetricSub, and then pushing the data to BMC Helix, okay? And then I can monitor different things. Yeah, this one. Oh, it's not. Sorry, to show that, for example, host power, for example, is being collected. So, and again, these are the metrics that are pushed, and these are OpenTelemetry metrics, right? And are pushed and available in BMC Helix. Again, for alerting, for correlation, etc. So it's not collected by any specific mechanism. We are leveraging open standards only, and then all the features of the BMC Helix platform, which is actually incredible. Something else, okay? But you may ask, but okay, Bertrand, Why? Yeah, what's the point of using OpenTelemetry? There are many, because then you can move one collector from one platform to another. It's standard, etc. It's the last collector that you will be ever using if it's done in OpenTelemetry. But it also OpenTelemetry defines what we call semantic conventions. Semantic conventions say, okay, how to name, for example, CPU utilization. CPU utilization is named systems that speed up utilization and systems that speed up time. Because before, you had, everybody came up with their own variation of the term CPU utilization. CPU util, processor utilization, proc time, PRCR, processor time, PCT, processor percentage, idle time, CPU dead time, whatever, So then when you want to aggregate data, when you want to correlate data, well, it's impossible, even for something as basic as processor utilization. Now it's different. When you use OpenTelemetry in OpenTelemetry collector or metrics hub, for example, the metrics are standardized. It's system utilization for Windows, for Linux, whatever, etc. Temperature, it's temperature everywhere. It's the same parameter, which then allows us to simply query data and aggregate that over your entire environment. So with OpenTelemetry and collectors like Metrics Hub and a backend like BMC Helix, you get true observability even for the infrastructure, not just the application. I'm showing a few examples. I could run that in the platform, but then it's going to take me too much time. So for example, this is the query to expose the entire storage capacity in your environment. Okay, here we have 200 terabytes. Then memory usage, for a system, it's always that query, system memory usage. Okay, for CPU usage, it's a bit more complicated actually. So you calculate the same by rate, etc. of the system CPU that time, and then you have precise calculation, aggregation over time, over host, over CPUs of the processor utilization. Power usage, that's interesting. Then for this one, you need something like Metrics Hub. Metrics Hub, by the way, which has been named one of the main collectors for OpenTelemetry by Gartner. So this simple query gets you the power usage in your data center. If you want the carbon emissions of your data center, well, the formula is a bit more complicated, I have to admit, but it's still just one query. To get this number, people hire consultants to work for weeks to get this number once a year. Here you can have it live in BMC Helix dashboard. Same for temperature. Then temperature optimization, I'm not going to go through this one. Before I conclude, I just want to show you a last screen so you can see the entire thing. So we have so we are in BMC. This is another tenant. It's not the demo tenant. It's where we send the data for internal Sentry data. It's been running for 1 hour. So we can see the data being collected for one system, okay, but then it's aggregated for one site. So this is the power of observability in the proper platform with the proper collector. Again, this is just leveraging Metrics Hub in this case, OpenTelemetry and the OpenTelemetry collector and BMC Helix, pushing data like energy usage, temperature, for example, in my systems, and the overall summary here. So this is done in pure OpenTelemetry, Open Standard, Open Collector. Then go back here, and that's how we're computing this too long presentation, too much slides, and not enough demo. I'm very sorry. Well, truly, I mean, this is the future. This is the future for, well, it's now with BMC Helix and Metrics Hub. If you're already a customer of BMC Helix and you already have the Sentry bundle that comes with BMC Helix, you already have full access to the Metrics Hub collector. You're entitled to use it, and you can use that to push data to BMC Helix, where you can leverage it in discovery, operations management, and dashboards. And then on top of that, service management and AIOps. Well, with OpenTelemetry, you'll be covering everything from cloud to on-prem infrastructure, from basic applications to full services, from many different sources. OpenTelemetry is the way to go. And I'm saying it's the future because all new developments will happen there. Trust me. Thank you very much. I hope you enjoyed this presentation and demos. And well, if you have more questions, we don't have much time, but still here to answer any question that you may have.
We do have a couple actually, and I can see Razim is just about to answer one of them. In fact, he's just answered it. So we've got one left in the Q&A. This was from Bertrand, another Bertrand. Hello, Bertrand. So if I understood well, the BMC exporter is OTLP. Could that replace intelligent integration from BMC? Is this correct?
Oh, it could, yeah. It could, but the OpenTelemetry, the intelligent integration for OpenTelemetry is there to consume traces, if I'm not mistaken. That can be confirmed by Anmol.
Yeah, I think it's probably different levels of functionality right now at the moment, But so for right now, you probably have the two of them in play. But over time, I think that when the functionality reaches parity, maybe it could replace it. Yeah.
Traces on one side and metrics on the other one. The BMC Helix export on your OpenTelemetry collector only handles metrics for now.
Yeah, that's true.
Can you hear me?
Yeah, we got you.
Yeah. So the question is more or less to import Prometheus metrics in Helix. We have the Prometheus collector intelligent integration, and my question was, could we replace that with the OTL with the exporter?
Totally. It depends on the way you want to implement it. Really, with OpenTelemetry, it gives you a lot of choices, and intelligent integrations gives you a lot of choices as well. So you can leverage the OpenTelemetry collector because, for example, you need gateways, aggregators, etc. You could even leverage the OpenTelemetry collector to gather different data from in your environment in Prometheus, and then have it exposed it through OpenTelemetry as Prometheus exporter, and then use intelligent integration. It's really flexible. You can do whatever you want. But to answer your question directly, yes, you can use OpenTelemetry collector with the BMC Helix exporter to push data to BMC Helix.
Okay, thanks, Bertrand.
You're very welcome.
Thank you for your question. Yeah, thank you. And I can see, Razim, you're answering another question in the Q&A. We're not sure who that is because it's anonymous, but do you want to take that question, just recap on it? You're so quick that as soon as I start talking, it's gone.
I just answered that.
So this was, the question was, can OpenTelemetry plus BMC Helix exporter replace current Sentry HWKMs? And you've obviously answered and said, yes, that can be replaced with Metrics Hub.
That's a very good question. That's the future of all Sentry modules. So we will be adopting OpenTelemetry protocol and using Metrics Hub to replace every single Sentry module that's there.
Yes, and don't worry, if you're already a customer of Hardware Sentry, the KM, you're fully entitled to use Metrics Hub in replacement.
Thank you, whoever asked that
any
question.
existing customer, sorry, Sam, it's just about to say, if any existing customer needs assistance in adopting Metrics Hub to use OpenTelemetry, go with the OpenTelemetry and Helix, they can reach out to us anytime if they have existing Sentry modules installed. So we can help them transform towards Metrics Hub.
Thank you. Okay, I don't think we've got any other questions. John, before we wrap up, I don't know if there was anything else you wanted to finalize as well, just as a call to action.
Yeah, I think we're okay. I think the usual, like reach out to your account manager, speak to us if you need POCs, demos, answering RFPs, or even just some hints, tips, and tricks when you're talking about adopting and deploying OpenTelemetry. We did see some interesting answers in the poll today where people they are thinking about doing it. There's about 76% of people said they were actually thinking of doing it. So reach out to your BMC account manager and we'll get those conversations going for you. And that's probably it, Samantha. We're tight on time. Yeah.
Great. Thank you. Thank you, everyone. And thank you, Bertrand, for presenting. I know we could have done with another hour. And
Yeah,
thanks to your team.
totally. I wasn't done at all.
You loved it. Yeah.
Indeed. And we
Yeah.
will be sending this out to everyone. I'm sure we'll be doing some more webinars with Sentry, but guys, there will be a survey that's coming out. All of the content we've shared today, just give us 24, 48 hours to get that together. Thank you for the team that's presented today from John and I from BMC
Yeah.
Helix, and hope to see you all again soon. Thanks, everyone.
Okay.